So, welcome to my presentation here on the Energy 4.0 conference. I'm going to be talking about training for the operator of the future. And before I go into that, I want to clarify something. So some people out there might have expected a KSG presentation when they read my name. Don't worry, I'm still with KSG, I'm still with the Simulator Center, but for all of you who have not been here in the March event and have not heard the news there, we are currently rebranding. EcoSim is our new brand that we use to promote our simulator services. So besides the look and feel, everything is still the same. No worries. We are still doing simulators, and we still believe if you want to plan and control dynamically the digital twin, the simulator is your best bet. Yeah, sorry for the interruption. Continue. So what we think as the core value of EcoSim is that we have to go that our simulators will pass the Turing test for simulators, what I normally call it. Turing test because we think that the quality of the simulators we deliver is that high that in the future simulation and reality will be identical. And as for the Turing test for computers, where you don't determine if you are talking to a computer or a human, with our simulators in the future, you should not be able to determine if you're sitting in front of the simulator or in front of the real plant. That's the goal where we are heading with our simulations. EcoSim is one of the new brands that KSG came up with. It's one part of a family that I just briefly want to talk about because we came up with the EcoTeam, that's how we call it. So we have 4 new brands available. One of them, as I already said, is EcoSim, where we promote our simulator services, and I'm going to talk about what we are doing there in my presentation later on. The other part is EcoLog. This is the brand for our data center that we are hosting here in our facility in Essen. Co-location data center, available rack spaces we have there, managed services, cloud connections, everything needed for the digitalization aspects that we are currently facing. So when you need computing power, you can put it in our data center. Very secure, very high availability, of course, as you know it from a company coming out of nuclear. Next to it, we have EcoSafe, which is our brand for human performance optimization, as we call it. There we focus on safety standards in work behavior. Of course, if you did technical training for a very long time, you realize also that the biggest error is normally the human being who is operating a plant or is doing a task. And with the EcoSafe brand, we are focusing on the human behavior, the soft skills training, and to set up safety standards in all branches. Last but not least, we have the EcoSec brand. EcoSec is our cybersecurity branch where we do consultation in cybersecurity, IT security, OT security, of course, very important for our power plant customers, doing audits and helping our customers to raise IT security. This is, of course, a very important topic for the future and very necessary because no one wants that his asset is getting hacked and he cannot supply the services that he wants to do. Well, so that shortly as an introduction to the new EcoTeam, the brand family that we set up here in the Simulator Center. So every time you see something Eco, remember that was KSG. That is the Simulator Center, so don't get confused by that. Okay, before I'm gonna talk about the training for the future operator, I want to go a bit back in what I presented in my March presentation in the last event. There I was talking about the Energiewende, the energy transition here in Germany. I was citing some results out of a study that was presented by a big think tank in Germany, our paths that we laid out to become carbon neutral or also carbon negative country until 2050. Two big contributors to that we need to focus on is, of course, the energy sector and the industry sector who have large emissions and will mostly contribute to the carbon reduction goals that Germany sets itself. And why I was talking about that in March was the change in the energy landscape that happens with this energy transition, especially for a simulator company that is providing operator training, is a very large step because the energy landscape will change dramatically. And the three major points, the major takeaways that I wanted to give back in that presentation that we also need for this upcoming presentations were the following. With the energy change, with the transition that we're doing, we will have many standardized, decentralized assets, small assets in our grid in the future. Of course, we are phasing out of nuclear, we are phasing out of coal-fired plants, so there will be no big power plants around anymore. We will have some backup CCGT plants in the grid, but the big utilities, as you know them from the past, the dedicated simulator users, as I would say, are not around anymore. There's a new possible customer coming up, and that's all the industry customers, because they have a large target for decarbonization. Just showed you the slide before that they can contribute a lot to the carbon dioxide reduction plans. And getting all the process heat, getting all the process steam in a decarbonized way is a huge potential for a simulator company to assist the industry in achieving these tasks. So the actual question I was raising back in March was, do you know your customers? Do we know our customers of the future? How will the energy landscape look like? And who will be the companies that need simulation services in the future? And from that starting point, where we already see that the energy landscape and the customer base will be changing a lot, I want to push it one step further and talk about the future operator in more detail. Of course, we all know the tendencies that are going on currently. The personnel, the number of shift personnel is continuously decreasing. The megawatt per operator fraction is going up, so each operator is responsible for more and more production capacity. And he, of course, he or she needs to be better trained then, and it's very important that the remaining personnel that is there has a good overview over the plant to secure its availability. Well, alongside of that goes the increase in automation. Automation level in plants is continuously increasing, and some DCS companies already have the goal, and also some plant vendors have the goal to bring up operator-free plants in the future, so assets that are running fully automated, no human intervention needed anymore, just for supervision, because for the regulatory bodies, of course, you need to have someone that is at least supervising the assets, but not controlling, operating them anymore. And this is another aspect that you need to take into account as a simulator company, because the energy landscape is changing, the plant assets themselves are changing, and if you're doing operator training and there are less operators, well, you need to think what else you can do with your simulators. And one important part of that is what is currently happening with artificial intelligence that is moving into operations. You probably also have heard some talks at that conference, or probably also have read a lot of articles and presentations what is going on with artificial neural networks, with machine learning, deep learning, however you want to call that, and how it's going to be applied to power plant operations. Just some examples I wanted to mention here, where we got into contact with that. One, of course, is the virtual power plants that are coming up currently. That's what I call, or what is called, when you combine photovoltaic, wind, biomass, small assets to one big virtual plant, and there artificial intelligence is used for the forecast, because, well, you need to know what the weather will be in the future. You need to know what your load prediction is in order to run these plants efficiently and also secure, and to ensure grid stability. So that, of course, is an application for artificial intelligence where this is used for forecasting. I don't want to go down and talk about predictive maintenance and condition monitoring. You all know this is kind of state of the art, where also new technologies like machine learning and big data analysis are used to do these tasks, like predictive maintenance and condition monitoring. I lately have heard lots of talks about artificial intelligence in waste incineration plants. They always have the problem, they don't know what they are burning, or they have less knowledge about what they are burning, what's happening in the furnace, and there are long dead times in the process. So some companies have applied artificial neural networks on waste incineration plants to do the optimization of the furnace performance, to use them to control primary airflow, secondary airflow, grade speed, and all that. And what they're doing is to take a time slice of past 15, 20 minutes, feed them into a neural network, and predict the outcome of the furnace in the future. And therefore, they can, for example, react on CO peaks before they are visible on the measurements, which is a hard task for normal DCS systems, and where AI proved itself superior to normal control mechanisms. So that is one way of having AI operators, so to say, in the plants. And well, going forward, of course, we are talking about fully automated operations, building up knowledge graphs of plant operations, using these knowledge graphs to react on situations in the plant, using machine learning to do fault detection also. I had some conversations with a company that is using AI and is capable of finding faulty equipment in transient behavior with a very high signification rate, so very reliable. And I think it's just a matter of time until the AI operators have taken over the plant operations, and that humans will just be supervising that, because that is still needed, as I mentioned, from the regulatory body. The question is, where's the path for the simulator company, and where are the limits to that? And when it comes to artificial intelligence or big data, one part, of course, is always data. You can only train your neural network on data that is available. And if you have no data yet, or if you have bad data available, then the outcome of your neural network will be a badly trained neural network. In one presentation, I heard the sentence, "We are training our network to be the best operator." But the question always arises, what happens if you don't have any good operators? And your plant is not running in an optimal way, then you can only train your neural network to be suboptimal. That's definitely not what you want. Another part is, of course, the question about malfunctions. Malfunctions happen in plants, but normally you don't have that much data available for the plant performance under malfunctioned equipment. So what your neural network can do with that is it can detect there is some fault, it can raise some alarm to the supervisor, it maybe can automatically shut down the plant, but operating the plant with faulty equipment and having training data for that is a task that is very tricky currently because, as I said, the data is not very high available for training. Biggest problem that you have when you go for AI operators or for fully automated plants is you don't have any data if your plant is not yet built. Period. There's nothing you can do. So you need to run your plant to gather data that you can use as training data. And each and every plant is different. So it's very hard to transfer neural networks from one plant into another plant because, yeah, they might be the same type and they might be very similar, but in operations, it comes down to nuances and the data is always very different. Same thing is with major upgrades that you have. Well, you have no data of the performance of the plant after you did the equipment upgrades. There you would also need to gather data before you can retrain an AI. And as I said, the supervision problem is still around. You would need some human to supervise the AIs. I don't see that this will be obsolete in the near future. So there are some limitations for going down the path of artificial intelligence in power plants, but we as a simulator company see that as a chance because as I think I stressed in my previous slide is it all comes down to data, and everything a simulator can do is of course providing data. You can run your simulator in different scenarios. You can build a simulator before the plant is already in operation. You can get the data, the training data from the simulator. You can use the simulator to validate your trained neural network, because what's happening currently is you take a time slice of the past of your plant in operation, you pick out some training data, and then you have the rest of it is validation data. But it's static data. So if you put an AI on static data, you don't get the feedback from the plant and from the process. It might do something that will screw up your process completely. So if you bring a trained neural network onto a simulator, it will directly get the feedback, and this is a huge benefit to me. And as I said, we can run the simulator in malfunctioning equipment and also train the neural network to operate on that. So there's a big chance and a big field for simulators to be also useful when you're talking about artificial intelligence in power plants. And the future AI operator training is probably something that we will need to do. As a simulator company, we are facing this opportunity. We have the chance to deliver the high quality models that are good enough to be used as training data for AIs, and with a digital twin of the plant, of a simulator of the plant, it will be possible to transfer AI from the simulator to the plant, do the training on the simulator, and then if you have major equipment upgrades, you can do that on the simulator, retrain the AI, put it on the plant and have it running directly with the new equipment. And as a side effect also, if you have an AI operator, you can use it for simulator maintenance tasks also. This is a very nice benefit. So as I said, there's a wide field of applications where simulators come into play when you're talking about AI operations. And I would be happy if we can continue the talk about that, probably at our booth. Just come by, have a chat. We can talk about that and see if we have the same vision of the future. I'm shortly running out of time, I see. So, as I said, there's a lot of things going on in the simulator market, and I wanted to bring some more examples of what we're doing at EcoSim, just very briefly, and then this would conclude my presentation. So. One thing we are currently doing is methanol synthesis simulation. one application for carbon capture and usage. We're taking carbon dioxide out of a waste incineration plant, combine it with green hydrogen, and produce methanol there as a synthetic fuel. We're doing the simulator assisted engineering there and getting very useful insights from the simulations. Currently, we also have a R&D project to use computational fluid dynamic models in our real-time simulations. This looks very promising. We're doing a proof of concept there, and with this step, we would also boost the fidelity of our models. Our instructors were tired of starting up, shutting down test procedures in the simulator, so we did a full automated test suite for the simulator where we can run startups, shutdowns, test procedures overnight. It's not yet with AI technology, it's just scripted technology, but it saves us a lot of time. And we can also talk about that, how we did that. And to be able to exchange models easier with vendors, with special equipment vendors, we implemented the functional mockup interface standard in our simulators for co-simulation, for model exchange. And this widens our capability of coupling models, for us a very important step. So I think I was slightly over time. Sorry for that. Yeah, my contact data, if you have questions about what I was just talking about, or if you want to continue the discussion, just come to the booth or contact me. You also find me on LinkedIn. I'd be happy for any contact and for any discussion. Hope you liked the presentation and enjoy the rest of the conference. Thank you.